Hi guys, it's me Muhammad Moin. Welcome to my YouTube channel. In this video tutorial, I will be discussing Numpy and Pandas. First of all, let us start with Numpy and its inbuilt functions. Numpy is basically used to create a multi-dimensional array. As you can see written over here as well, Numpy is a general purpose array processing package. It contains a high performance multi-dimensional array object and tools for working with these arrays. So what is basically an array? Let us first understand this. So an array is basically a data structure that stores values of the same data type. And what is the difference between an array and list? Python list can contain values corresponding to different data types, while array in Python can only contain values corresponding to the same data type. So let us first see how we can install Numpy. To install Numpy, if you are working on Anaconda Navigator, just open the command prompt and write pip install Numpy. You can also write pip install Numpy as np, and so it says requirement already satisfied because I have already installed it. So in this way you can install the required package of Numpy. So let us discuss further. And so I have told you how to install Numpy. Then you need to, in the next step, you need to initialize, or you can say import Numpy. You can initialize or import it by writing import Numpy as np. Np is basically a short form. While doing coding in the next steps, we can easily call Numpy using np. We don't need to write Numpy. We just write np and we can call Numpy. So first of all, if you to create a Numpy array, we will write my dash list, just considering a general list 1 2 3 4 5, and array is equal to np.array my dash list. So it creates an array, Numpy array. So if by checking the type array, it comes out to be Numpy array. And if I check the size of the array I have created, it's 5. It's 5 comma. It's basically a one-dimensional array it has created. So now to check what is my array, I can just write over here. So this is basically what I have created an array over here, Numpy array. One thing you need to remember that in one-dimensional Numpy array, we have a single bracket over here. In two-dimensional Numpy array, there will be 2 square brackets. While in three-dimensional Numpy array, there will be 3 square brackets over here. So here you can see we have only one single square bracket at the start and one single square bracket at the end. While in the two-dimensional array, we have 2 brackets, square bracket at the start and 2 square brackets at the end. So in the next step, let us see how to create a two-dimensional array. So here I have given just list my dash list 1, my dash list 2 and my dash list 3. Now here I have created a two-dimensional Numpy array. So here you can see that if I check the size, it turns out to be 3 comma 5, where 3 represent the number of rows and 5 represent the number of columns. So here you can see we have 5 columns, 1 2 3 4 5, and we have 3 rows. Now let us see how many elements we have in a Numpy array. So it turns out to be 3 by 3 cross 5 is equal to 15. So while doing any array reshaping, you need to write the sequence in the reshape that gives you the product of 15. For example, here my original array size is 3 comma 5. So if I do 3 multiplied by 5, it means I have 15 elements over here. So while reshaping, I will write the sequence in such a way when I do its product, it turns out to be 15. So let us do it more clearly. So if I write 5 comma 3, originally I have array of 3 rows 5 columns. So if I want to reshape it of 5 rows and 3 columns, let us see it. So it turns out to be 5 cross 3 15 again. But if I write 5 cross 4, it is giving me 20. So this is not a correct way to reshape it, given error. So here you can see it gives an error because cannot reshape array of size 15 into a shape of 5 cross 4, which is giving 20. So I hope it's clear. Now how to index an array. So if you have a one-dimensional array like here, if I see, so here I have a one-dimensional array. So if I want to access the second index element 0 1 2, so will just write, if I want to index the second element, this is basically 0 1 2, so it will give me 3. So here I am just checking the size of my array, multi-dimensional array. So if I want to access in a multi-dimensional array to do indexing, if basically these are my row elements and here I have my column elements. So while doing indexing, this is my 0 row, this is my first row, and this is my second row, and this is my 0 column, this is my first column, this is my third column, this is my fourth column, and this is my fifth column. Oh, sorry, I made a little mistake. This is my 0 column, this is my first, this is my second, this is my third, and this is my fourth column. Now if I want to access these elements 5 6 and 8 9 only, so where they lies, this is 5 6 and 8 9 lies in the 0 first and second row, while in column if I say 0 1 2 3 and 4 column they lie. So I will write first row till the end row, and then the third and fourth column, so I will write 3 dash 3 column. So here I will basically write my row elements, and here I will write my column elements. So in this way I can access 5 6 my given sequence. So if I want to only access 5 8, I will write in the first row we have 5, and in the second row we have 8, so I will write 1 colon and 3 colon 4. So in this way we can access the 5 8 sequence. So let us now look at some inbuilt functions as well. So first let's look at, we have an arrange, which is a basically inbuilt function. So if I want to create an array from 0 to 9, so what will I do? I will just write np.arrange. It basically 0 means the start step and 10 means the stop step. So here I will writing 0 basically, which is my start from where my array will start, and 10 where my array will stop. So I will writing 0 comma 10. So here my array will starting from 0 and it's ending at 9 because 10 is my stop step. So if I want to create an array but there should be a difference of 2, so I will give it at step size of 2, step is equal to 2. So it is creating an array with a difference of with a step of 2, like 0 2 4 6 8. So if I write 3, it will create an array with a step size 3. So 0 3 6 9, basically it creates an array where each sequence has a difference of 3 with the next element. So this is all from Numpy. Now we will look at pandas, and we will now further explore pandas. Now in the second part of this video, I will be discussing about Pandas. Pandas is a software library written for the Python programming language for data manipulation and data analysis purpose. It offers data structure and operations for manipulating numerical tables and time series. So as you can see over here, Pandas is a fast, powerful, flexible and easy to use open source data analysis and manipulation tools for the Python programming language. So first of all, if you haven't installed Pandas, just go to the command prompt if you are using Anaconda Navigator and just write over here pip install Pandas. As I've already installed, so it might be, you can see our requirements already satisfied, it will be written over here. So let us just see over here as well. So if in the previous part of the video I have told you how to install Numpy, so here we are going to discuss about Pandas. So as you can see over here, requirements already satisfied. So after downloading the required after installing the required library, in the next step you need to import it. So like here I have done import pandas as pd, and previously I have also installed Numpy, so I'm writing here import Numpy as np and import pandas as pd after installing the required library. So first of all, let us discuss what is basically data frame. Data frame is basically a combination of rows and columns, and it also has data inside it. So a data frame, what does a data frame contains? It contains the data first of all. Second, it contains the number rows and the columns. So as you can see here, the first parameter in a data frame is data, and data is in 2D format. So data must be in 2D format. The second element is index, and the index is based on the number of rows, and the last element is columns. So first let us discuss this thing, and the second element is based on index and the index is based on rows. So what does it mean? I hope there is a lot of confusion in your mind. So first of all, I create a data frame using Panda. So first of all, I create a data frame by writing pd.dataframe, and here I am giving np.arrange 0, 20. So here I am using the built-in function of numpy, which is basically arrange, to create an array which basically starts from 0 and end at 20. So here I am just creating an array which basically start from 0 and end at 19 of 20 elements. And dot reshape, what does it does basically, it reshapes into 5 rows and 4 columns. So as you know, the first element in the index is 4 rows, and the second element is columns. So it just basically converts that array into 5 rows and 4 columns. So here I am basically writing the index parameter, the second parameter. I am writing the name of my rows, row 1, row 2, row 3, row 4 and row 5, and the column and I'm just writing the name of my columns. As you can see here, we have 4 columns. So column 1, column 2, column 3 and column 4. Now let us check that data frame. Here I have made the data frame by the name df, so I'm just writing here df. So this is basically my data frame. It has 5 number of rows and we have 4 number of columns here. So you can convert your data frame into a CSV file by just writing df.to-csv and the name of that CSV file you want to create. So df is basically my data frame and I want to convert it into a CSV file, so I'm just writing over here. So you can now ask where is that CSV file created. So if you go over here in the home tab, just wait a minute, it's opening. So if you scroll down here, we have created by the name test. So I think we need to scroll down. 11 of PQR. Here you can see here test1.csv a CSV file has been created by the name test1.csv. As you can see here, we have that our data over here. So you can download it as well and open in an Excel form as well. So how to assess the elements of my data frame? How I can assess the elements of my data frame? There are 2 methods to assess the elements of the data frame. The first method is .lock method and the second method is .ilock method, which is basically index location and is basically dot location. So what is the difference between these 2 methods? Let us discuss this as well. In the .lock method, you always focus on the row indexes, while in the .ilock, which is basically index location, you focus on row as well as column index. The first element, or you can say the left side of the element, left hand side of the element represent the basically row element, and the right hand side represents the column element. The left hand side represents the row and the right hand side of the element represents the column element. So as I have told you, we basically use .lock for row indexing. So here I have written the name of my, for example, I want to assess the elements of row 1, so I will write df.lock row 1. So I have assessed the element of the row 1. So if I want to assess the elements of row 3, I will use .lock row 3 here to assess the elements of row 3. And if I write type df.lock row 3, so it gives me a series of series. It's not a data frame because here I don't have the columns, I only have the elements which I have in the row 3. So it as you can see here, it is not in the form of data frame, so it's giving me the type of series. Now as I have told you, from to .ilock we can assess row as well as column elements. So if I want to assess the element from the row 1, if I want to assess the element from the row 2, basically, which is basically 1 basically represent the second index, 0 represent the first index, and 1 basically represent the second index. So we have on the second index, as you can see here, we have row 2, and in the second index over here columns, we have column 2. So if I want to assess the second index of row as well as column, so I will write here the first we have rows, and in the left hand side we have rows, in the left hand side I have told you we have the column elements. So if I want to assess the element from the second index of rows as well as column, so I will write 1 colon comma 1 column. So it gives me the elements from the second index of rows as well as element from the second index of columns. So if I check this type, it gives me a data frame because we have a proper form of data frame. It has rows as well as columns, and this is basically my original data frame. So if I want to convert my data frame into an array, so I will just write dot values. After the name of my data frame, which is basically df, I will write dot values. It will convert that data frame into an array, as you can see over here. So if I want to count the elements in any of the column, for example, I want to count the elements in my column 1, so I will just write df column 1 dot value dash count. So here you can see we have 112, we have 14, we have 16, we have 1, we have 8, 1, we have 0, 1. So if I want to check the unique elements in my column 1, we have 0, 4, 8, 12 and 16. So we can use dot unique command to check the unique elements and dot value dash counts to count the number of elements in column 1. So this is all from this video tutorial of Numpy and Pandas. Hope you have learned a lot. So thank you for watching the tutorial. See you all in the next tutorial. Have a good day. Bye bye.